Friends, we are going to see part B of question 5 here. I'll explain briefly the question that is being asked here. At time 0.75 seconds, the object spring earth system has a total kinetic energy K naught and the total potential energy is U naught, and the same kinetic energy and the potential energy is at this particular time. That means at these two moments, this and this, at these two instants, the kinetic energy of the system is the same. At these two moments, the kinetic energies of the system are the same, and the potential energies of the system, they are the same. The question says, explain how this graph is explaining this fact here, that at these two moments, the kinetic energy is the same and the potential energy is the same. Okay, right. So we'll see. I'll try to illustrate how the kinetic energies are the same and the potential energies are the same for the two given instants. I know that the total energy of the system is equal to the kinetic energy plus the potential energy, right? The kinetic energy is given by half mv square, right? And the sum of kinetic energy and the potential energy at any given time is constant. Okay, the total energy of the object spring earth system is the same at all times. So Ke plus P together has to be the same at all moment. I know the kinetic energy is given by half mv square. That means if at two different instants the kinetic energy has to be the same, if it has to be the same, the velocity, the speed here, the v represents the speed of the object. Speed has to be the same because m mass is obviously the same. Speed here of the object will be given by the slope of this position time graph. This is the position time graph given for the object, right? So the slope of this graph at any instant will give me the speed. The magnitude of the slope gives me the speed. So let's locate these two instants. 0.75 is this position here on the graph, and 1.13 is here. Okay, the slopes have to be the same. Okay, if I make a tangent here, it's this. Okay, and a tangent here, it's this, right? These two tangents are parallel. That means their slopes are the same. If the slopes are the same, if these two tangents are parallel, the slopes are the same, that means the speed is the same. Hence, the kinetic energy is the same. Okay, that explains part 1 here. Why the kinetic energy at these two particular instants have to be the same. Now coming to the second point. Second question. Briefly explain why the total potential energy of the system is the same. It is evident from this thing here. The kinetic energy at two different instants is the same. The potential energy has to be the same. Why? Because their sum is fixed. Okay, this thing is fixed. If this component is same, the other component has to be the same as well, right? So that explains the part 2. So this explanation given here is sufficient to explain this question. Okay, thank you.